Hello, good morning everyone, or good evening, depending where you're coming from. Hope everyone had a good week. Hope everyone had a chance to go through the first video, go through the exercises. I added a couple of exercises as well. And I hope you have your clusters ready, because today we will talk about, we'll basically continue what we started last week. So last week we talked about Kubernetes pods, we talked about replica sets, and we talked about deployments. So today, what we're gonna do today is, if I switch to the slides. So today we'll talk about Kubernetes Services. I'll explain the different types. I will show a bunch of demos. There's also a lot of hands-on labs for you to go through. Then I'll talk about Ingress. We'll talk about Kubernetes Ingress and explain how you can bring, how you can expose multiple services to the public from your cluster. There's a lot of different examples there and demos and labs for you to go through as well. And then finally, I added Jobs and CronJobs here. I do have the slides. I do have the exercises and the labs and everything prepared. However, there is a lot of hands-on work for services and Ingress, so I don't know if we'll get to it. I'll try to get to it. If nothing else, I'll get to it. I'll explain. I'll talk about it, and then we can part ways, and you can go through the labs yourself, and then I can answer the questions next week. All right. I see some people in the chat. Can you just guys give me a thumbs up if all is good? If you can hear me, if you can see me. I always have this fear of forgetting to click the go live button, or people not being actually able to hear me. I'll wait for a couple of seconds. I know there's a delay, just to make sure that people hear me. All right, perfect. That's awesome. Okay, well, so let's get started then. So last time, when we talked about pods, I mentioned how pods are mortal, right? And once they die, they're gone and they won't come back. That's why we said you should never go and create your pods manually. You should always use a replica set or pretty much deployment to do that, to create the pods. So let's think about this scenario, right? So we start with a deployment. And in deployment, we're saying we want a single replica, one replica of the pod running. The pod starts, and it gets a unique IP address. Now, let's say we try to make a request to that IP address, right? Let's say we are inside the cluster. We can access that IP address. We can make a request. Everything works fine. Everything is good until it isn't. So the pod will die, and what that means is the deployment will bring up a new pod. It'll start a new pod, and that pod will get another IP address, which is unique. So that IP address is not going to be the same as the previous one. So this is the problem, right? It is very clear that you cannot rely on pod's IP address to reliably access or reach the pods. And this is where the first resource we're going to talk about today, called Kubernetes Service, comes into play. So Kubernetes Service is an abstraction that defines a logical set of pods, and it gives us a way of reliably reaching the pods. So the service keeps a list of endpoints, and endpoints in this case are pod IP addresses. And then whenever we make a request or try to call this service, the service will load balance between the pods, and it will actually direct the request to one of the pods or one of the backend endpoints. So these endpoints are also kept up to date. So anytime a new pod starts, or the pod crashes and a new one gets added, or you scale your deployment up or you scale your deployment down, this endpoints list will get updated. The way this is done is there's a controller called the service controller that monitors the pods and makes sure that the endpoints list is kept up to date. So, services defined, logical set of pods. They maintain an array of endpoints, which are IPs. Pods come and go. The controller updates the list of endpoints. Now, the way that we define the set of pods that services load balances across is through the labels. So remember last time we talked about labels and selectors. So we labeled our pods with a name. We could label it with a version, environment, pretty much any combination of key and value that you wish. You label them. And then in a service, we use a selector to say, this service selects all these pods. For example, select all the pods that have a label called app set to hello world, for example. So these services, as I said, they provide a reliable and a fixed IP address that, unlike with the pods, the IP address won't change. So there's no concept of services being automatically deleted or recreated and things like that. So usually when you create a service, you're going to create the service. You're not going to go and recreate it like 10 times, right? It's not going to magically disappear and reappear again, right? So IP address of the service will only change if you go, or someone else, right, goes and deletes the service and recreates it, right? Now, in addition to the IP address, you can also use a DNS name to reliably reference the service, right? So let's say we called our service hello-web. We can use that name to access the service, to make requests to that service as well. So you can imagine having hello-web Kubernetes service that's backed by some Hello Web deployment that has any number of pods. And then from your, when you're trying to call any of those pods, you could do hello-world, hello-web, and use that name to access any of the pods, or the IP address, but the name is, of course, preferable way to do it. So here's an example of how a very simple service looks like. The logical set of pods that I talked about is defined by a label selector. So this is on line 8. And in this case, we have a single label called app, my app. And this means that any pod that has that label set will be included in the list of endpoints for this service. Now notice from line 10 to 13, we're also defining 2 ports. So on line 11, we have a port that's set to 80, and this is the port for the service. So this is where this my app service can be accessed on. Another port that's set here is on line 13. It's called target port, and target port can be used to define the ports on the pod itself. So remember, in the pod, you can have one or more containers, and those containers can expose different ports. So target port is something that tells the service, when you call this pod on 10.0.0.1, use the port 3000. Also, whenever the service gets created, there's a DNS service inside the cluster that creates a set of DNS records. So in this case, we have a service called my app, and we get a DNS entry called my app and my app.default. Default is the name of the namespace. If we deployed the service in a different namespace, it would be the name of that namespace. So using just the name my app, you can access that service from within the same namespace. Using the second option, my app.default, or name of the service dot name of the namespace, you can use to access services running in different namespaces. In general, it is a good practice to always use the full name of the service when you're referring to the service. So use the service name dot namespace name. All right, so let's go to the first demo and the first lab. Let me just switch over. Okay. If I can find my screen here, perfect. All right, so I already have a cluster. Let me just make sure that everything is connected. Yep. So I have a cluster, a clean cluster, nothing's deployed. So what I'll do is I will deploy just a simple hello world, create a simple hello world deployment. As a recap, if you look through it, we're creating a deployment. We're calling it web-frontend. We're setting this name label to web-frontend. We want a single replica of the pod. We're defining the selector here, and notice that this is the selector that tells the deployment how to reach the pods. And then in the pod template, we're setting the same label for each pod, naming the container using this hello world image, and then setting a container port here. So what this is saying is that this image right here listens on a port 3000, and this 3000 will be the target port that we will set later when we create the service. So let's create this. I'll just wait for this to start. By the way, feel free to type any questions. I am looking at the Discord. I've also added it to the screen so I can see it easier. Okay, so we have the pod is running. We can also look at the logs. So I don't remember if I showed this last time. So let's do kubectl logs and the name of the pod, and this will actually show you the logs from the default container in that pod. If there's a single container, it'll show you the logs of that specific container. If you have multiple ones, you could do -c and then you can say container name, whatever the name of the container is. Anyway, from the logs, we see that this is just an Express application, and it has started, and it's listening on port 3000. So this is the port that the container listens on. Another way or another command that I want to mention is the output command. If you set it to wide, this will actually list all the pods, but it'll also show the node that the pod is running on, as well as the IP address, right? So it'll show you the IP address of the pod. So if we would, let's delete this one. It's deleted, so we'll wait for it to get recreated. And you'll notice that when the second one was recreated, it actually got it received a different IP address. All right, so let's say we know that this application is running, or website, very simple website. I don't know if it deserves to be called a website, a hello world application, I guess. So it's running on, we know that it's running on port 3000. We have an IP. However, this is not gonna work, right? If we try to curl directly to this address, it's not gonna work because we're not inside the cluster, right? You have to be inside the cluster in order to reach that IP address. So what I usually do is, and this is just for testing and debugging purposes and all that. So I usually run a command, something like this. So I'll type it out, but I do have an alias for it called kbash. So what that command does is I'm running a pod called curl that uses this specific image, and there's a bunch of other images. You could create your own image if you want as well. So what this will do is this will actually run a pod inside of the cluster, and it will give me a terminal inside that container that's running inside the cluster, right? So from over here, if I list the environment variables, you'll see these are the environment variables of that container that's running inside the cluster. So let me clear the screen. Now that I'm inside the cluster, I could actually curl. I have to do port 3000. I can curl to that pod IP, and you'll notice I get back hello world response, right? So I am inside the cluster, and now I can actually reach that pod. So if I exit, by the way, I have a alias set or a function set called kbash that does this automatically for me, so I don't have to type it out. And then I think the pod will eventually go away. Let me delete it. But you could also run the command in such a way that whenever you exit the container, exit that container, it will automatically delete the pod. So you could do, I think it's rm -- remove. Yeah, so if I exit here, the pod will be deleted automatically, right? But usually I keep it running, and then you can use, let me show you again. So if I run this, exit, you can use attach command to attach to the curl pod, the curl container in the pod, and then get the actual interactive terminal back into that container. All right. Let's now talk about the service. So as I mentioned, it's a way to reliably reach the pod IP addresses and the backend endpoints container for the service, or the service container rather, maintains the list of endpoints. So let's create a simple service. So this is very simple, as I had in the slide, very similar to what I had in the slide. And we're setting the labels. Note that these labels up here in the metadata, this is just labels for this service. This could be completely different. It doesn't have to be the same as the selector here. But down here, we are actually setting the selector labels to, let me try to open another window here. We are setting the selector label to app.kubernetes.io/name web frontend. And down here, I actually listed all the pods with the labels. And you'll notice that this is one of the same labels that we have set on that pod, right? So we're saying the service will load balance across all these pods. As for the port, we're saying we're setting it port to, whoops, not what I was expecting. Okay. In ports, we're setting the port 80 for the service itself, and then the target port, this is the port on the pod, we're setting it to 3000, and we're naming the port HTTP. So let's create the service, and let me exit this one down here. Okay, so now that this is created, we can use the get command and use get services or get service or get SVC. All of them are the same to list all of the services that are running in the default namespaces in our case. You'll notice we have the web frontend service here. The type of the service is ClusterIP, and we'll talk about this today in a little while. We also got a ClusterIP for this service. There's no external IP, and the port is 80, right? So this ClusterIP that's assigned to the service will not change until we go and delete this service. So if I run my curl container again, and if I try to notice that I don't have to do 3000 here now, right? Because we're not directly calling the pods anymore. We are indirectly calling the pods through the service, but service is exposing the port 80, right? So I can remove that 3000 here. So if I curl directly to the cluster IP for this web frontend service, I'll get back the same hello world response that I got back before or earlier when I was curling directly to the pod. The difference being is that now I have a reliable and a stable way or stable address or name that I can use to access the web front end pods. So this is the IP. I've also mentioned the DNS, right, and the name of the service. So we can use the name of the service to do the same thing. And then another option is to fully qualify the service name by appending the name of the namespace name where the service lives in. So this works as well. And there's a third option where if you want a really fully qualified name, you would use .svc.cluster.local. And cluster.local is just a local domain of the cluster. And this will give us the same result as well. Okay, so let's look at I just exited the curl container. So let's look at the endpoints a little bit. Let me show you how that works. So I'm describing the service, the web front-end service. And this is just a more friendly display of the service. And it gives you more information than just doing a get. Labels, annotations, this is the selector, the type of the service here, the IP address of the service, target port, and then in the endpoints here, let me list the pods and show, just do it wide. You'll notice there's a single endpoint, 1092.26, and this one corresponds to the IP address of this single, of the single pod that we have running. Now let's say we want to scale the deployment. So let's say the front end, scale, replicas equals, let's do 5 of them, right? So let's do this. So you'll notice there's 5 of the containers. 3 of them are still being created. 2 of them are already created. And now if I describe the service, you'll notice there's way more endpoints here that are being created. And an easier way to do this is to use kubectl get endpoints. And this will actually show you the web front end, and it'll show you all the IP addresses, for the pods that specific service is watching over. And then similarly, scaling it down, scale it down to 1. If I watch the endpoints, well, it was really fast. So there's only 1 here now because we scaled it all the way back to 1 service. All right, so let me delete this, and then we'll take maybe 10 minutes for you with your clusters to go through this. By the way, the labs are on. If you go to live.startkubernetes.com, that will take you to it'll take you to the Notion page, and in the Notion page, you'll notice there's session 2, and talking to pods. That's the first lab for you to go through. All right, so let's do. I'll switch to the timer. I'll turn off my camera and the mic. Feel free to ask questions, and then we'll continue in 10 minutes. All right, I'll continue slowly. All of those labs and everything will be available anyway. You can always ask questions on Discord. Okay, so let's talk about service types. In the demo and in the lab that you hopefully went through, you might have noticed that there was a type of the Kubernetes service, and the one that we've created in the lab, it was called the ClusterIP. So every time you create a Kubernetes service, that service has a type. If you don't provide anything, as we didn't when we created our own service, the service type is set by default to ClusterIP. Now, in addition to ClusterIP, there are other service types in Kubernetes: NodePort, LoadBalancer, and ExternalName. Those are the other 3. So let's go through each one of these and try to explain how they work, or moreover, what they're used for. So you would use the ClusterIP. This is the typical one. This is the default one. You would use this type of service to access the pods from within the cluster through a cluster internal IP address. So just like we did in the lab where we created the web front end service name, you could have imagined we could have multiple services, multiple applications running in the cluster, and then we would use that name, web frontend, or whatever the service name is, to access the service. Using this type, you can define the port you want your service to be listening on. So in our case, we did port 80. We could have picked any other port pretty much. And then in addition to that, we've also configured a target port, and that's the port on the pod side. So where the containers can be reached in the pod. Now, ClusterIP is nice, but at some point you probably want to expose your services to the public to allow external traffic to enter your cluster, to host your website, host your services, host your application. The NodePort service, what this one does is it opens a specific port number on every node, every worker node in your cluster. So if I have 5 nodes in the cluster, I create a NodePort service. This NodePort service will be exposed on each one of the nodes that have different IP addresses, but the port number will be the same. So any traffic that's sent to node 1 : port will go through the service and actually reach your pods. So you would use this type of service, the NodePort type, when you would want more control over the load balancing. So what you could do is you could expose your services through the NodePort and then configure your load balancer, if you are running your own load balancer, to use the node IPs and use the node ports to load balance across those IPs. Second scenario is where, let's say you're migrating an existing solution to Kubernetes, for example. In that case, you might already have your application running on VMs, and you probably have an existing load balancer. So what you could do is you could create this node. You could move the portion of your application to Kubernetes already, and then use the NodePort to expose it on the nodes, and then add that node IP and the port combination to your existing load balancer. Talking about load balancer, there's also a service type called LoadBalancer, and this is the way to expose the Kubernetes services to external traffic. Now, we are running a cloud-managed cluster, so we're running our cluster in GCP, but in every cloud provider supports this. So whenever you create a service, Kubernetes service that has load balancer type, what will happen is that the Kubernetes cloud controller, so controller for that specific cloud vendor, will actually create a load balancer in your cloud account. Right? So it'll create a load balancer. That load balancer will get an external IP address, and then you will be able to access your pods running in the cluster through that external IP address. The last one is the external name, and this is a very particular type of service that does not use selectors. So instead of using selector, it uses DNS names. So what you can do is with external name, you could map a Kubernetes service to a DNS name. So when you would send a request to the service, when you try to access it, it will return the CNAME record with the value in the external name field instead of the service cluster IP. So the reason you could use this, or you would use this, is if you're migrating workloads to Kubernetes. For example, you could keep your database running outside of the cluster, and then you could use my-database service to access it from the workloads that are running inside your cluster. All right, so let's go to through the demo. These service types are the easiest to understand if you're actually showing the demo and showing how they work versus just talking through them. Okay, so I still have that web front end running. I still have one instance of one replica running. And we'll start with, just close something here. I will start with the NodePort service. So let's do a NodePort service. Let's create that one. It looks exactly the same as that ClusterIP service that we've created earlier. The only difference is here where under the spec, we're explicitly calling or setting out the type of the service, and we're setting it to NodePort, right? So this is just telling Kubernetes, hey, I want this service to be of the NodePort type, which means expose this service on exactly the same IP, on exactly the same port on every node in the cluster. So let's do this one. Let's create it. And then if we list the services, you'll notice that the web front end is created. The type is NodePort this time. It also gets a ClusterIP, no external IP because it's not exposed externally per se. But notice the difference here. So the port here is 80, but then there's a colon here which is saying it's mapping to this NodePort number. And this is the port number where we will be able to access this service from each node. So let's look at the nodes. So I'm using the wide output, and this one shows you the external and the internal and the external IP addresses of your nodes. So what this is saying with the NodePort is that I could take this IP, any of these three, and I could say curl this IP, and then instead of port 80, we want to use the NodePort, which is this one. And note that you can set this yourself if you want to, but it's recommendable to not set it to any specific port number and just let Kubernetes figure it out. That way, you might not you're not gonna pick any port that might have been taken, right? So if we do this, this should theoretically work, but of course it doesn't, right? Because this does not have, like, there's a firewall. You cannot access, you cannot just access the specific port. So what we have to do is we can modify the firewall rules and just create the NodePort rule that's going to allow this specific 30683 port, and the project name is start Kubernetes -live. So if you're following along, the only thing that's different on your in your cloud instance will probably be this one, the project name. It all depends what you call your project, and of course the IP addresses. So the IP addresses and the ports will be different, right? So if you're following along. Okay, so this will create the rule. Shouldn't take too long. Perfect, right? So it created this rule, Ingress, so it's coming in and allow this specific port, right? So now if I try to curl to that same IP address, which is our first node, and use this 3683 port number, this time I get back the hello world response, right? Similarly, let me clear my screen. It's much easier if it's on the top. So if I curl to this one, does anyone remember what the I don't remember what the port number was. Okay, let's get it. All right. So if I curl to this second IP with the same 3683 port, works as well. And then just because we want to prove that everything works, of course, 683, third one, so this works as well, right? So what this has done is we just exposed, we opened that specific port on the nodes, and you could imagine you could now go and either create your own load balancer and then use these external IPs with this specific port to access your service. Or if you have an existing load balancer, you would go and update the backends in your existing load balancer and enter these IPs and these ports in there. All right, so before I continue, I will delete that rule that I've created, just so we don't leave it open for anyone else. Start Kubernetes -live. So does Kubernetes checks if anyone else has? Yes, if you, Kubernetes will pick a port that's not taken. And I think there's a specific range. I don't remember exactly what is range. 30,000 to something is the range of ports that Kubernetes will pick. So yeah, if you are creating, if you're not explicitly setting the node port number, Kubernetes will pick one that's not taken. So should be fine on that one. Okay, so let's delete the NodePort service now. So I'll say Kubernetes delete service, web frontend. And the next one that we will create, so we've already shown the ClusterIP. The next one that I'll show is the load balancer. So let me paste it in here, the YAML. This should look very familiar. Again, the difference is only in the type here, where we're saying we want the load balancer type. So let's do this. Now this one will take a little while, and I just listed the services. You'll notice the type is set to load balancer, but you'll also notice that the external IP column shows pending. In the previous two, it was showing none because there wasn't really any external IP address that was being assigned to the service. But in the case of the load balancer, what's happening here is the let me see if I can switch to my window, and I'll show you the all right, there you go. So this is my cloud account. So if I go to load balancer, if I go to load balancing, there you go. So this was, I mean, it's very clear that this is not something that I would have created. If you know me, I would never pick this name. So this was created automatically for us with this very friendly name. We got the IP address, we got the port, and then the backends are actual 3 nodes that I have running in the cluster. Let me switch back to the Cloud Shell. And this time, if I list the services again, we should see that there is an external IP address. So if I curl to this external IP address, I'll get back hello world. And also, if you want to go and curl to the same IP address from your machine, you should get back the response as well, because I mean it is a public IP, right? So I got the hello world, right? So this is how you could. Again, I'm not advocating for you to create a Kubernetes cluster and run your website on it, right? But this is how you could run something in your cluster and then expose it to the public. Okay, so now it's time for you to try this out. This is the service types lab in the Notion, and then we'll do let's do 10 minutes again. I'm very, like, I know the 10 minutes it's usually not enough, but let's do 10 minutes and try to get to as much as you can, and then we'll move on to ingresses, and we will talk about Ingress. All right, we're back. My OBS crashed in between, but I think I It didn't really disrupt the stream, so that's good. Yeah, I can see myself in YouTube, so that's perfect. So there were a couple of questions on like different protocols that are supported. Yes, you can use HTTP, you can use TCP as well. You just need to change the protocol name. The name itself, the name value, is just the name of the port. It can be, I think it can be pretty much any name. But of course, you should name it something that makes sense. All right. So we've shown how to expose a single application if you wish through a load balancer, right? But we know that's usually not a realistic scenario, right? Like if you do decide to run a Kubernetes cluster, you're not going to create a cluster just to run a single application out of it, right? You'll probably run multiple different applications, you'll have multiple different microservices, and you'll probably expose multiple different things out of your cluster as well. Now the question is, how do you do that, right? How do you expose multiple services or applications to the outside world, right? The first answer that comes to mind, the solution is, well, just create multiple load balancers, right? Sure, you could do that. Like, let's say you're running 50 different applications, or you want to expose 50 different applications. You can go and create 50 load balancers if you want, right? But I'm not up to date with the latest cost, but I'm pretty sure it'll be fairly costly, right? If you're running 50 different load balancers. There's a more natural and cost-efficient way that we can expose multiple services. And of course, it's by the way of another resource that's called the Ingress resource. So I'll show the YAML first, and then I'll go through a more detailed explanation on how it works and what's involved. So the Ingress resource, you can use it to manage external access to the services, to the stuff that's running inside your cluster. Using this resource, you can define the different rules on how the services inside the cluster can be accessed. In this example, you'll notice on line 10 and line 14, we're specifying some rules and we have some paths, right? We're saying, oh, if the path is /blog, then I want to go to service name called my blog service on that port, and so on. However, this resource alone is useless, right? It is just a collection of, it's just a configuration, right? It's a collection of rules and a collection of paths, but it needs something, that has to be something else that these rules and these paths can be applied to. And that something is called an Ingress controller. So this Ingress controller acts as a gateway, and it routes based on the traffic. It routes the traffic based on the rules that are defined in the Ingress resource. So when we're talking about Ingress resource, here are some of the things that make the Ingress resource. So, Ingress controller. So the controller is usually a Kubernetes deployment that runs one or more pods with containers that are running a proxy server pretty much. Like it's running Nginx, it's running Envoy proxy, AJ proxy, whatever. In addition to that deployment, there's also a service, Kubernetes service, that's used to expose these Ingress controller pods, these Nginx's, these AJ proxies, right? Additionally, there's also usually a set of some supporting resources for the Ingress controller, configuration maps, secrets. We'll talk about this next time, about the config maps and secrets. But you can imagine if you want to do SSL, for example, right? You need a way to configure your Ingress controller, your Nginx, your proxy, configure with the certificates, right, to do the TLS, right? So that's the first portion of the. Whoa, I'm sorry about that. Moved it a little bit. So that's that first smaller box that says Ingress controller on the slide, right? So it's basically a service that load balances across the pods. Those pods are running the actual proxies, Nginx's, right, envoys. And then there's also a set of YAMLs, right, that are supporting those pods, right? Now, there's also a load balancer. You see the load balancer on top of it, right? Now, there's no, like load balancer is not necessarily part of the Ingress controller when we're talking about the Ingress controller. However, that service that's used for the Ingress controller, the service that's used to access those pods, can be of a load balancer type. So when you deploy that service, as we've seen in the lab, that will trigger the creation of a load balancer in your cloud account, right? So that's just a means, just a way for your traffic to enter the cluster. And then after that, the Ingress controller is going to route the traffic according to the rules. So the idea here is that you deploy this Ingress controller, you deploy this proxies, right? You expose that proxy by the means of a load balancer Kubernetes service. So you get a public IP address. Then you can use the Ingress resource to actually create the traffic rules and decide how the traffic is going to flow to which services inside your cluster. So similarly, if you think about outside of Kubernetes, how you would do this, right? You would probably have a load balancer. That load balancer would probably point to some proxy servers, right, to Nginx Envoy. And you would have a configuration. Those proxies would be configured to route the traffic to specific IPs, specific addresses, based on the rules. So let's go back to that same YAML that I showed in the preview, like 2 slides back. This one might make more sense now. So what we're doing with this configuration is what we're saying on line 7. So line 6, those are all the rules for the Ingress controller, which is just a proxy in our case. And in this rules, we're saying for the host called example.com, we have 2 paths defined. One path is /blog, the other one is /music. So practically what we're saying here is if someone types example.com/blog and it's going to reach that Ingress controller through the load balancer, what we want to do is on line 11, what we want to do is we want to route the traffic to a service called MyBlog service that's running inside the cluster on a port 5000. So this is service name and this is service port. So this is just abstracting it out. We're not talking about pods at this level. We're just talking about the service, right? And then in turn, we would have a service called MyBlog service of a ClusterIP type that will listen on port 5000, and it would have some target port to whatever ports the block service pods are running on, right? And then same thing for on line 14. We're doing exactly same thing, just a different path, and we're directing the traffic to different service on a different port. Now there can be additional settings in the metadata. Specifically, there could be annotations that you can use to configure the controller and basically tell the Ingress what type of controller it should be using. But all this depends on the Ingress controller that you're using. And in the demo and in the lab, we will use the Ambassador Ingress controller. I think that Ambassador is based on an Envoy proxy, but there's also Nginx controller, and there's a bunch of other controllers out there that can just do a search for them, right? Usually the installation is extremely simple. A couple of lines, right? A couple of kubectl commands that you have to run to just install it quickly for the demo. Again, caveat here, we're not talking about running production stuff here, right? Just for you to try it out. If you want to run any of these things in production, you'll actually have to go and make sure you've configured it properly. All right, let's do the Ingress demo. And just find my windows here. Okay, so let me delete. Oh, looks like I lost connection. Yeah, for some reason the Cloud Shell editor has been flaky on me this week. It's been like I had to reconnect very often for whatever reason. And I also discovered, by the way, that there's a limit on the time that you can use the Cloud Shell editor. I think it's 50 hours a week or something. I hope I never hit that limit. All right, so I'm just deleting the leftovers here. So I've deleted the deployment, and I will delete the service as well. And then we'll go into a scenario for the Ingress controller. So the scenario that we'll do is, let's imagine we want to run 2 websites in the cluster, right? So we have first website, which should be very familiar, and it's called the Hello World website, and it just shows the Hello World World message. That's the first one. And the second one will be a website that's called Daily Dog Picture that just shows you a random picture of a dog whenever you reload the page. So let's go ahead and deploy the Hello World. Shouldn't be anything new here. This is exactly the same as the web front end that we used before. It's just different naming. So deploy this one. Then the next one, we will deploy the dog picture website. We'll create a deployment. Exactly the same. The only difference is the names here and the image that we're using. So let's deploy this. Just list everything to make sure that both of them are up and running. I think it's pulling the image of the dog picture website, the Docker image. And the Hello World one we already had, so it was pretty fast. Okay, so we have the 2 pods running. Now, we have the deployments, we have the pods, we also need the services to be able to access those deployments, to access those pods. So let's deploy 2 of the services. Notice if you can deploy multiple configurations in the same file if you want to. You just have to split them with three dashes. So the first service is the dogpic service. We're specifying the selector, we're specifying the port, and then the same here for the Hello World. We're specifying the port and we're specifying the selector. All right, let's look at the services. Perfect, so we have 2 of them, port 3000, and just to be extra sure, I created a pod inside the cluster. Curling to Hello World, that works. And then if I curl to the dogpic website, it's called dogpic service. That's the name of the service. Port 3000. We get way more stuff here, but it's just a proof that it works. Okay, so before we go and create the Ingress resource, we need to deploy the Ingress controller, right? And the job of this controller will be to receive the incoming traffic and then to route the traffic to services inside the cluster based on the rules that we will define. So as I said, I'll use the Ambassador API gateway, but you can use Nginx, whatever you want. And I'm not going to go into details explaining the installation here. If you go to getambassador.io, it's pretty much installation instructions there. So the first thing that I'll do is I'll just deploy the custom resource definitions that Ambassador uses. And then the next one, we will create the actual deployments. We will create the actual like cluster roles, role binding, service accounts, auth rules, and 2 deployments, I think. So if we list the deployments, you'll notice that we have a deployment called Ambassador and a deployment called Ambassador Agent. And I think it will take a little bit. Again, it is first time you deploy something on your cluster, assuming you haven't deployed it before, it takes a little while because the cluster needs to, the nodes need to pull down the actual images, container images, so they can start them. But this shouldn't take too long. Let's see. And this is the actual. Let's actually look at the. Let's describe one of these pods. Describe one of these pods. Yeah. So this is the image that's being used, and this is the actual proxy this is the actual Ingress controller, the proxy that will run, right? That will take there you go. So now we have the 3 of them running. So this is the proxy where the traffic will hit. So what we need to do now is we need a way to expose, we need a way to access these pods externally, right, from outside of the cluster. And the way we will do that is we'll create a load balancer service. So let's do labels. So yeah, the label that we will use is this one. It's service equals ambassador, so that will be our selector. And then I think if let's do describe pod, just describe this one. And the port will be 8080, right? So that will be the target port on the container. So let's create this service, the load balancer one. So what we're doing now, so we created the deployment that runs the proxies, but we also need a way now to access those proxies, right? And this is pretty much up to you to decide how you want to do this, right? Like in our case, what we'll do is we'll just create a load balancer and target those pods, right, with the selector. But you could use NodePort if you wanted to and did your load balancing on your own. It's all up to you, right? So you're not locked into what Ambassador wants you to do, right? You can do it. You can do it yourself, right? So let's wait for this one to. Oh, that was fast. Okay, so we already got the load balancer. So the service that we've created, we already got the external IP address. So now we can try this out. Let me actually just open another window. I've installed this Cloud Shell application. That's a separate application. It's not really Chrome. So let's do this one. Okay. So what I'll do here, I'll paste in the IP address of that load balancer service that we've created. And then if we go to Ambassador V0 V0 diagnostics, we can actually access the proxy server diagnostics page. Of course, this is again, this is just for testing. This is just for demo purposes. You have to turn this off if you're going to run this in production, but you have to figure that out on your own, how you want to do that. So this is just telling you the version of the proxy, the host name, the ID of the cluster. So it is using Envoy. It's giving you some, does some checks, right? If there's any errors. Looks like there's an upgrade. We're not going to upgrade right now. A couple of links to get started. And then the actual like route table And I think you can drill into this. And this is the actual like Envoy configuration that you can look at that does the route matching and all the details that you would need if you wanted to debug your proxy. Okay, so let's switch back to the Cloud Shell. Okay, so now we have the Ingress controller up and running, right? So we were able to use the external IP address and that specific path name to access the diagnostics page. We can now go and create the Ingress resource to actually configure how we want to route the traffic, right? So anytime someone goes to this IP address, we want to configure it where they should land. So let's do a first simple one, where we have a single service Ingress. So we're creating the Ingress resource. Note that I'm adding these annotations here, which is just basically saying that the Ingress that I'm using is Ambassador. And this is a well-known annotation that you can look up, Kubernetes.io, and you can look it up, and you'll get the specific value for if you're using like Nginx, then you'll use Nginx here, right? If you're using AJ proxy or any other proxy, you might use something else. So what we're doing here, we're just setting a default backend. And this default backend is just saying whenever someone hits this external IP, just go to the hello world on the port 3000. That's it, right? That's what we're saying with this Ingress resource. So let's do this. And then of course, just like with any other Kubernetes resource, you can list it. You can use kubectl get ingress or get ing for short. We get the name of the Ingress. Notice the host is set to a star, meaning that we don't have any host defined. Later we'll show how you can define rules for specific host. Example would be, let's say you have your domain, hello.com, and then you want to configure routing based on that domain. And then address ports and how old the resource is. So if we try to, if I go back to this page, and I just go directly to the IP address, you'll notice that I get back the hello world message, right? So this is what we've gotten with that Ingress rule. If I didn't have that Ingress rule, I wouldn't have gotten any response back, right? Because the proxy wouldn't know how to route the traffic. Okay, if we go back to the original idea, we have hello world, we have the dog website running, right? And we want to expose both of them through the Ingress. The way we can do this is by writing some rules. So in this next example, I'll show you how to do routing based on a path. So what we want to do is we want to route traffic from, if someone goes to the IP address /hello, we want to route to the hello world. I think hello world is what we called it, right? The service. And if someone goes to /dog, we want to run to the dogpic service, Kubernetes service, right? So let's see how to do this with the Ingress resource. Notice that I didn't delete the previous resource, the previous Ingress resource, and that's because I'm using the exact same name. And because I'm using apply, what happens is that Kubernetes will automatically change the resource and update the resource for me, right? If I would use create, I would get an error, I think. It would actually say, oh, my Ingress already exists. Okay, so what we're doing, we're actually defining the rules here. We're defining two paths. The first one is /hello, and we are setting it to prefix. I think that just checks that the prefix is set to /hello. I think there might be other settings here where you can do some more, a little bit more advanced matching. And then we're just saying route the traffic. The backend for this path is this hello-world service that's running on port 3000. And then similarly, oops, I lost my screen for a bit. Similarly, we're defining a path for the dog service, and we're just routing it to the dog pick service. So let's deploy this. If I switch back to can you hear me now? I think I was muted. My mistake. Can you guys hear me now? All right, perfect. For some reason, OBS crashed for the second time. Okay, let me switch to that same IP address. So what we did is we configured the Ingress resource, we configured the /hello path and /doc path. So now if I refresh the page with just the IP address, I get nothing back, and I get 404 back, and that's expected because the Ingress doesn't know, right? There's no rule. We haven't specified what to do if someone comes in on just the host, right? Just the IP address. However, if we do /hello, you'll notice that I get back hello world, and then if we do /dog, you notice that we get the dog picture. It looks like the CSS is not loading, but you get the idea, right? You get the picture for this one. Okay, so let's look at how this shows up if we, if I describe the Ingress, right? So let's describe the Ingress. By the way, when you're describing resources, you don't necessarily have to specify the resource name. And if you don't specify the resource name, it will just show all the resources, right? It'll describe all the resources that you have. Okay, so let's do that. There you go. All right, so we haven't set any hosts, so that's why this one is set to star. But we do have two paths configured. So /hello will go to hello-world, and then /dog will go to the dog pick service. And I think these are the actual IP addresses of the services themselves. So this is a nice way. If you use describe, it will actually show you how the traffic is routed based on the path. Now that's good and nice, but practically you're never gonna give your customers an IP address that they can go and access your website on, right? You need, or more sophisticated than that, and you would usually use a domain name, right? So let's see how we can do that. So I actually don't have example.com. That's not my domain, but you can put in any host you want. This is just for testing. Yeah, I'm not gonna demo how you can actually hook it up with the real domain name, but it's fairly straightforward, right? Assuming you bought example.com and you have access to the DNS records, what you would need to do is you would go to the DNS records for that domain. You would create an A record, and in the IP address for that A record, for example.com, you would just paste in the external IP of your load balancer service. That's it. And that would do the connection. When someone types in example.com, it would actually resolve to that IP address. All right, so this looks exactly the same. The only difference here is that we're specifying a host, right? So we're saying when someone comes in to the front door and says, I'm the example.com host, this is how we want to route the traffic. Note that there's no rules. We're not saying anything about blah.com or something.com, right? We're ignoring, so we'll get 404 for those, right? So let's deploy this. And let's describe the Ingress. Let's describe the Ingress. It looks exactly the same. The only difference here is that we have the host defined now, and we're saying that these rules are specific for the example.com host. So let's see how this works practically. So I'm back on my doc picture side. So what I'll do is I will just try navigate to the IP, and this won't work because remember there's zero rules, right? We haven't set any rules. Same thing if I go to if I go to /dog, nothing. If I go to /hello, there's nothing. There's no rules. I think you get that, right? So what I'll do is I have this extension called mod header, and what this one does is it can modify your headers before the request is sent or when the request is sent. So you can fake the host, right? In our case, we will fake that we're coming from example.com host. So I'll set that one. Now refreshing this, nothing's gonna happen again. There's no rules for, if we go to example.com, there's no rules for that. However, if we do to /hello, this time it works. We get to hello world, and then /dog, we get to the daily dog picture as well, right? But now, as I said, if you wanted to use this with a real domain, you would go to your domain registrar, you would go and update the DNS records there, and then you would create an A record that will actually point to the specific IP address, and then we would be able to type example.com. Okay, let's back to the Cloud Shell. Now, there are scenarios where you want to set a default backend, meaning if none of the rules match, this is where I want the traffic to be sent, right? This can be configured. There's different ways that you can configure this with different Ingress controllers, right? However, like you could, for example, set it in an annotation somehow, and that would be configured automatically. But we could also set it in the Ingress resource itself. I mean, practically, you would probably, the best way to do this is to actually set it based on how Ambassador wants you to set it with the annotation or something. Or you would do any other way of do the routing, and you would not even maybe use the default backend, right? So this is an example of setting the default backend. We can set it here at the top. Outside of the rules, we're just saying the default backend is this hello world on the port 3000, right? Let's do this one. Now if we describe the Ingress, you'll notice that we have the default backend up here, and it is set to hello world, right? So what does that mean? If we go back to the web page, I still have that example. Let me just double check that I have it set. Yes, I still have the example host set. For some reason, I can't zoom out. Let's see. Oh, there it is. Okay. So dog works, /hello world works, but then if we do /blah, it shows not found, but this is actually telling us that it works. It does go to the hello world. However, I'm not listening to /blah on the hello world, right? So that's why it's just returning me a not found. But you'll notice that it is different than previously where we would get a 404, right? Also, if I go just to the IP address, I'm also going to get back hello world, and that's because we do have that default backend set. Okay, let me switch again. And the next scenario, we will look at how we can not just use one host, how we could use multiple hosts to do the routing based on that, right? So we'll route example.com to hello world, and we will route dogs.example.com to the docpic service. So we're not going to use we use the path for the hello, but not going to use the /dog for the path to the dog service. So let's show how the YAML looks like here. I also removed the default backend. So we have two hosts now. We have example.com and we have dog.example.com. Note that this could also be anything else. Let's do something different a little bit. Why not? It's not like the unprepared demos never work, right? Okay, so let's do, instead of dog.example.com, we'll say dogs.com, just dogs.com. So let's do that. So I just modified the YAML. There we go. So I have two hosts. Example.com goes to the /hello on the hello world, right? And then this one, dogs.com, will just go to the docpic service. So let's deploy this one. Okay. And now that we have this deployed, if we describe it, so I'll describe the Ingress, you'll notice that it actually shows two different entries, two different hosts. We have example.com /hello will go to hello world, and then dogs.com will go directly to the docpic service. So let me switch to the browser so we can show this demo. So we have, there we go. So I do have example.com set. So if I do example.com /hello, I get back the hello world. If I go directly to example.com, I don't get anything because we haven't set anything. And then finally, if I change the host to, we said dogs.com, right? And I go directly to it, this is simulating going to dogs.com. I actually get the daily doc picture, and I actually get the CSS this time as well. So it looks a little bit better than before. All right, let's do, how are we on time? Yeah, let's do 15 minutes for this one because it is a little bit longer and maybe more involved than previous. My OBS crashed again. That's not good. Hope you can hear me. I will, okay, so let's do 15 minutes for this one. And then we'll come back. And I think we'll have enough time to go through Jobs and CronJobs a little bit. And then we will wrap it up for this week. So let's do 15 minutes. And I'll start and add some time. There you go. All right. Feel free to ask questions on Discord. All right, we're back. We're almost done. We have to go through the jobs and CronJobs, and then we are done for today. So up until now, the type of workloads that we were deploying were pretty much long-running applications. And what I mean by long-running is things like websites, APIs, backend services, something that keeps on running continuously. Now, and if something went wrong with those containers or the pods, they would get rescheduled and then they would start running again, right? Now, the other type of workloads that you often need to run are one-off things, right? Workloads that perform a particular task, and once that task is completed, you don't have to run it anymore. An example of a workload like that would be, let's say, doing a backup or generating sales reports, generating some daily reports, monthly, weekly reports, right? And I mean, you could have a pod that continuously runs, right, and consumes resources, but the report is actually only created once a day or once a week, right? But if it only needs to run like when it's actually generating the report, when it's actually doing the job, uh, uh, it's much better than just to leave it running continuously, right? So once the task does what it's supposed to do, once it creates the report, it can go away, right? Also, if the task fails, if the container fails for some reason, you can configure it in such a way so it restarts automatically until it completes successfully. So Kubernetes features a resource that's called the job, and you can use a job resource to run such type of workloads, right? So the job resource can create one or more pods, and it can track the number of successful completions of those pods. The job resource itself will ensure that the pods are run to completion and that they start and that they complete. Now you could do similar thing with only with pods without the job, but then you would have to be the one to manage the pod's lifecycle in case the pod fails or if the pod gets rescheduled. So here's an example of how a job could be defined. The template tells the job resource how to create the pod, how to create the containers, which image names to use, which labels to use, and so on. One thing to note that we are on line 11, we're explicitly setting the restart policy to never. By default, if you're creating pods, the restart policy is set to always, meaning if your pod crashes, it will always get restarted. However, job does not support that type of restart policy, right? So you can have it set to always. There's only two supported values here. It's either never restart the job, which the setting is never, as we have here, or on failure, meaning only restart the pod when it fails. So setting one of these values will either prevent the container from being restarted when it finishes running. So you'll see in the demo and in the lab that you'll do when we deploy this specific job, it will only run once and it will not restart. However, there is a way you can configure a job to be executed multiple times. So the job, the resource itself, the controller can track the number of successful completions, and then you can use that number to control when the job is considered completed. By default, the number of completions is set to 1. And you can change that by changing the completions field in the spec. So if we were to create a job that has the completions value or the completions field set to 5, the job would execute 5 times. Now, the next question, if we're talking about multiple completions, is how are these jobs executed multiple times, right? Is it in serial? Is it in parallel? And that's the next thing that you can configure in case you want to run if you want to run jobs in parallel, right? So you could set the parallelism setting, and instead of waiting for the first one to complete, you can have multiple of them start at once. Then there's also a question of errors. So what happens if the pod keeps failing, for example, right? So in that case, the job will just keep creating and retrying to create or restart the pod based on a setting called the backoff limit. In that setting, you can set it on the spec, and it specifies the number of retries before Kubernetes will consider the job as failed. So the default value that Kubernetes set this to is 6, and the jobs will be recreated with an exponential backoff delay. So the backoff delay means that if the first pod fails, the controller will wait for 10 seconds before recreating it, right? So it'll create the first pod, the job creates the first pod, the pod fails, the controller will wait for 10 seconds, then it'll try to recreate it. Then if it fails again, it'll wait 20 seconds and so on up until a total of 6 minutes of the delay. This backup delay will be reset either when you delete the pod or if the pod completes successfully. In addition to the backup limit, you can also terminate a job using the active deadline seconds setting. And this setting represents how long a job can run in total, regardless of how many pods it creates. So if we consider an example where we set, where we had like a where we had the pods failing, right? We could set the active deadline seconds to 10. And then I think in this one, we had the job that runs for 60 seconds, right? So we had 60 seconds in the previous example. Let's say we set the active deadline seconds to 10. That means that the job will fail after the 10 seconds, right? Because the job takes 60 seconds to run, but we have active deadline seconds set to 10. And then once that is reached, Kubernetes will terminate the pods and it will set the job's status to deadline exceeded. Now, another type of jobs are cron jobs, and these are the jobs that you can specify to run at specific times and dates. So when you create a regular job in Kubernetes, they'll start running as soon as you create them, right? However, you cannot schedule a job resource to run at the particular time or an interval. Of course, you could create a script to do that, but that's not the way to do it. The way to do that, to run a job on a specific schedule, is to use this cron job resource. So this resource uses a well-known cron format that's made out of 5 fields that represent the time to execute the command. So the first value represents the minutes, the hour, the day of the month, and then the day of the week. So here are just a couple of examples of how you could set this cron format, the schedule, right? The first one is all starts, meaning run this job every minute, every hour, every day, every month, and the day of the week. The second one is just running the job every 10 minutes. And then we have more specific ones where run at 9 a.m. and 9 p.m. every day, month, and day of the week, or run every 15 minutes, for example. These are like well-known settings. You can just Google the cron format, and there's a lot of, like, you don't have to figure this out and know what exactly this means, but just by looking at it, right? Okay, so here's an example of a cron job. Note that the templates are exactly the same or very similar as for the job. Now, you'll notice line 7 that we have the job template field, and this is where we're specifying how to create the job. And then if we go deeper to, let's say, line 13, this is how we're specifying how the pods will be created. Actually, line 9, right, the template. How the job will create the pods, right? So it's just a wrapper on top of the job. The addition here is line 6, which is the schedule field, where we've set to run this cron job every 10 minutes, right? Now, in addition to this, we can also configure how the cron job deals with concurrent executions as well. So once the deadline exceeds, the job will not get restarted, right? If you get the deadline exceeded, it'll just be considered as errored out. All right, so let's look at an example. Let's say we configure the cron job to run every 5 minutes, right? The pod will start, and then for some reason, the pod will run for more than 5 minutes, right? Like, we have a schedule to run the job every 5 minutes, but the first pod that starts, that actually runs the job, is taking more than 5 minutes to run. So what does the cron job controller, what does it do in this case, right? What happens? Will it create a second pod as per the schedule, remember, every 5 minutes, right? Or will it do nothing since the previous job is still being executed? So you can control this behavior, of course. Everything is controllable through the setting called concurrency policy. There's three possible values: forbid, allow, and replace. The default value is allow. And what this one says, if the previous iteration hasn't completed, when the new one is supposed to start, the allow setting will allow the second instance to run. So if you have it set to allow, you might be in a spot where you have multiple jobs executing. Setting the value to forbid will actually do the opposite. So the pod that was supposed to start per schedule will not start until the previous one finishes. Well, it will actually wait for the next cycle in the schedule. Finally, the replace setting will stop the currently running job, and then it'll start a new one on schedule, right? So you have allow, we don't care if there's multiple of them running. Forbid, which we say if an existing one is running, don't do anything, or don't start a new one. And then replace, which just means kill this one and start a new one because we want to be on schedule, right? Okay, so how about a scenario where you really want to keep a strict schedule, meaning that the jobs have to start on scheduled time, and if they don't, you want to mark them as failed. So you can control that with the starting deadline second setting, and you would set this in cases where you don't want to start the job over the specific scheduled time. So if the job does not start at the scheduled time plus that deadline seconds that you set, mark the job as failed. Here's an example. So let's say we have this job that needs to run every 10 minutes. So let's say the first job is supposed to start at 2 p.m. What this starting deadline seconds is saying that if the job does not start at 2 p.m. and 30 seconds, the controller should mark it as failed. All right, let's look at the last demo. Let me switch here. Okay. Way too many windows here. Okay. This guy. So we'll look at the jobs and CronJobs. And of course, I have to reconnect. All right, perfect. Okay, so let's run a simple job that doesn't really do anything. It'll just sleep for 60 seconds, right? So restart policy is set to never. I'm just running a busy box and then passing in the arguments that say sleep for 60 seconds. So let's do this. So if I list the jobs, kubectl get jobs, you'll notice there's the name of the job. It tracks the completions, which 0 out of 1, because by default the completion number is set to 1. And then the duration and the age. So if we describe the job, it's actually telling us down here in the events that it successfully created a pod called sleep on the job, which is the name of our job, and then the random string at the end. Let me list the pods. I still have this old stuff running, so ignore that one. You'll notice there's sleep on the job pod here that's running. It's not doing anything. It's just sleeping. Also, I don't know if I showed this, the way that you can list pods by specifying a label. So you can do -L Kubernetes, -L whatever the label name is, and then the label value. So if we list I can spell Kubernetes, there you go. We got this pod, and you'll notice that the status this time, it took me more than a minute to talk through this. The status has actually changed to complete it. And then if you also list the jobs, you'll notice that the completions shows, the completions field now shows 1/1, which means there was one completion and there was one successfully completed pod as well. So let's see what happens if we deploy another job that's called 3 sleeps on the job, and we are explicitly setting the completions to 3 completions. So let's list this one. Oops, job. So it says 0 out of 3 completions. And then as soon as so there should be 1 pod is running here, 3 sleeps on the job, right? It's still running, 13 seconds. So we have 40 more seconds to waste until the first one is completed. And then as soon as this one completes, if we would list the jobs, we'll see 1 out of 3. Now let's see what happens if we change the parallelism setting, right? And I'll use the actually let me delete the previous one, so it might be delete the job, this guy, and then I'll delete this one as well, just so it's cleaner. Okay. All right, so this is being terminated. Okay, so let's deploy same one as before, but this time we will set the parallelism setting to 2. And what this one defines is it basically says you can run 2 pods in parallel. You can run 2 pods at the same time. So let's do this. Now list the pods, and you'll notice that this time we have 2 pods that are being created and 2 of them that will be running in parallel. So as soon as these 2 are completed, then the third one will be able to run. Yeah, so it's still 0 out of 3, but the 2 of them are running. Okay, so we also did the what happens when the job fails if we set the and talk about the active deadline second. So let's look at that one. Get job. And let me delete this one. And you can imagine how you could use these jobs for like report generation, any task that you need to run, either on schedule or like one-off tasks that you would need to run, and you would just want to put it in a cluster, have it run, save the results somewhere, and then the job would be completed and it's not going to restart. Okay, so let's use the active deadline seconds here, and this setting just represents how long this job can run in total, regardless how many pods are created and all that, right? So we're setting the active deadline seconds to 20 here. However, each one of the pods takes 60 seconds to run. So after 20 seconds, the pod will get terminated and the job will actually fail because we exceeded this active deadline seconds. So let's do this one. And then let's get the jobs. I'll describe job, failing job. We have to wait another 6 seconds for this to kick in, and then we'll see down here in the events. There we go. So you'll see 20, 23, blah, 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 right? The pod was deleted. So the pod was created, the pod was running, right, for 20 seconds. Then it was deleted, and the warning here, the reason for the deletion was the deadline has exceeded, and the job was, because the job was active longer than the deadline that we specified. So deadline exceeded. Let's see, there was a question. For some reason, it's not showing me who asked the question. Nikolai. Okay. So let's see. Failing job, 0 completions. Let's see if it keeps running the... Yeah, no, it doesn't. It's not going to restart another job, right? So, right, the first one failed. There was 0 completions, and there was nothing here. This one just says describe job. Oops. Job, failing job. Yeah, I'll just say the deadline exceeded, and it's not gonna, yeah, see down here, 1 failed, and it's not gonna actually restart restart the pods. Yes. So I think that answers Nikolai's question. Okay, so let's look at the CronJobs as well. So let's configure one that runs every minute. So we're saying here, run a run job with this template every minute. The job will each pod will just sleep for 10 seconds, and then the next one will be created every minute, pretty much. So let's do the CronJob. So the short name is CJ here. If you want to list the CronJobs, and you'll see there's the name, there's the schedule, if it's suspended, active, and then the last time it was scheduled. There we go. So the last one was 9 seconds ago. So if we list the pods, so this one ran for 10 seconds, it was completed, and there'll be another one that will start. We just have to wait another minute, and based on schedule, the second one will start. All right, let's just see. I just wait for another minute here. Let me refresh for 20 seconds. Awkward silence for 20 seconds, unless someone has any questions in the meantime. Let's do. That should start soon. There you go. There you go. So you'll see that the last schedule was, it does take a couple of seconds for the pod to start and everything, right? But this one was saying that last was scheduled 63 seconds ago, and then over here it's just saying, oh, last one is scheduled 4 seconds ago, and one is actively running. And I think by this time it should already be completed. Yeah, there you go. So we have two of the completed ones. All right. This was all that I had for today. Let's do another 10 minutes for you guys to go through this last job and CronJobs labs. And I'll still be online for 10 minutes in case anyone has any questions. And then after 10 minutes, we'll just close out and we'll say bye until next week. So I'll be back in 10 minutes. All right. This is it for today. I hope this was useful. Hope you had the time to go through the labs. If not, live.startkubernetes.com. Everything is in that. It's in that Notion page, so you can go through it. I'll also add some exercises to it later today. Tomorrow, upload the slides. Thank you again. Next week, we'll talk about. So this is what I have for next week. I have configuration. We'll talk about config maps and secrets, and then init containers, different container patterns, and application health, how to do different probes. We're really good on time today. So hopefully we'll good on time next week as well, and we're not going to go over. So we'll cover all those things. Yeah, thanks again. I will just post the link to the feedback form. I would love to get some feedback on how this went, how this session went, or any other feedback that you might have, any ideas for what you want me to do next, any specific scenarios, things like that. Feel free to fill it out. Again, Notion is on live.kubernetes.com. Everything's there. And then if you have any questions, you can find me on Twitter, YouTube channel, Discord, and yeah, thank you very much for taking the time, and I will talk to you all next week, same time, same place. Bye.